All right, let's get started.
All right, so we are talking about X1 and X1e instances and scaling in-memory workload to up to 4 TB of RAM. My name is Pranav Parekh. I'm product manager in the EC2 group at AWS.
I'm Stephen Jones. I'm a director of solution architecture focused on enterprise workloads like SAP, Microsoft, Oracle, and VMware Cloud.
What we're hoping to do today is talk a little bit about the EC2 portfolio, dive deeper into the X1 and X1e instances, which are purpose-built for large in-memory workloads, and then pick one specific in-memory workload that a lot of our customers run on X1 and X1 instances, which is SAP HANA, and then dive deeper into how SAP HANA can be optimized and run on X1 and X1 instances.
Should we poll the audience? How many of you are X1 customers today? Have you used X1? All right, excellent. How many are thinking about using X1 instances for SAP workloads? All right, this should be interesting. All right, so I'm sure many of you are familiar with Amazon.com. It's a small retailer based out of the Pacific Northwest. We're applying many of the concepts that we developed over the years as we scale that business to IT infrastructure. I won't go into a lot of depth here other than we have global capacity ranging in a lot of different machines and services, which Pranav will go into here in just a moment. One of the key characteristics of the AWS cloud is that it's built entirely the same way every region. That is, there's global scale, it's built and operated, it's all available through API, so it can be orchestrated, and we'll get into some specifics, even for very large in-memory workloads like SAP. It's future-proof, meaning SAP customers, enterprise customers can actually build and plan for starting with small workloads and scaling to very massive workloads, and we'll talk about what that looks like here in just a moment. But everything we do really starts with customers, very similar to what you experienced with Amazon.com. Even our portfolio and roadmap, so the very idea and development of this platform with the X1e system up to 4 terabytes of RAM, there's a lot of memory in a single system, was actually designed and built based on customer demand. Customers often think when they approach the AWS platform that it's just about compute storage and networking. There's a vast array of a broad set of services that goes very deep as well into each of these services. Most often we hear from customers that they would rather not focus on things that aren't differentiating to them, right? And so we've developed services around not just compute storage and network, but also new interesting services like IoT, machine learning, deep learning, and I think there's many great sessions that avail you this week. Again, there's a lot of opportunities for you to learn this week. We encourage you to attend as many sessions as well. So at this point, I'll turn it over to Pranav, and he'll talk a little bit about the platform.
Sure, thanks. So with that, before we dive deeper into the X1 and X1e instance platform, let's talk a little bit about the Amazon Elastic Compute Cloud, also known as EC2. A lot of customers think that EC2 is essentially virtual machines and you can bring your workloads and run there. That's true, but EC2 also offers a plethora of services around that. And that makes it really interesting when running large mission-critical in-memory workloads. So first, it actually allows a series of different purchase options. That means you can run your instances as on-demand instances, or you can purchase reserved instances. It offers a choice of different instances, different sizes, different instance families optimized for different workloads. There is also a series of networking services. So things like virtual private cloud, things like elastic IPs, and a lot of other things that makes the overall networking portfolio suitable for running a lot of different workloads. And then user experience, so API, SDK, CLI, portal. So overall, the platform allows a lot of different categories of workloads and a lot of different use cases to be built on the same overall platform. So with that, let's talk a little bit about the instance families. So when we started EC2 in 2006, we started with one instance. We eventually called it M1. Then we realized that there are a lot of other workloads and a lot of other use cases that don't fit well into that M1 instance family. And with that, we started launching different instances optimized for different workloads. Today, we have general purpose, compute optimized, storage and IO optimized, accelerated instances, and memory optimized instances. What these instances do is it allows you to pick the right infrastructure for your workload. If you go to the documentation and look at all of these instances across all of these generations, it might look a little bit overwhelming. But the best way to conceptualize this is look at your workload and see if your workload is constrained by compute, memory, storage, or something else. If your workload is constrained by compute, that means you might want to start with the compute optimized instances that offers you the best compute capability. If you have a workload which, for example, your in-memory workloads that is constrained by the amount of memory you have in the system, then you might want to start with the memory optimized instance. And once you pick the instance family based on your workload, then within that instance family, you have the ability to select different sizes and figure out what size actually works well for you. And the flexibility that the platform provides around selecting one size, deploying your workload, and then moving that to another size seamlessly makes it risk-free in terms of trying a specific instance size or a generation. So today, we're going to specifically talk about the X1 and X1e instance family. So this was just the background to make sure that we're aligned in terms of what we are talking about today. So talking specifically about X1 and X1e instances, these are optimized for large in-memory workloads and other memory-intensive workloads. We had a lot of customers running in-memory workloads on R4 instances. And then we got feedback that we need higher memory. We want to scale our memory beyond what R3 and R4 instances offer. So we decided to build this X1 instance family, specifically for in-memory workloads and specifically for in-memory databases like SAP HANA. As we started talking to customers, we realized that there are a lot of other use cases where it actually provides a lot of flexibility and optimization, specifically around big data processing, like Apache Spark or Presto. In-memory analytics, a lot of our customers are running in-memory analytics workloads so that they can analyze the data in memory in real time. And the smaller X1e sizes, which start from X1e X large size, also allows a great solution for running high-performance enterprise-class databases like Oracle and SQL. So overall, these two instances, they provide a really good collection of infrastructure for running memory-optimized and memory-intensive workloads. So let's dive a little deeper into the X1 and X1e platform. Both of these instances are built on the same underlying compute platform with different memory profile. That means the underlying server that serves these instance sizes has the common compute architecture, but it provides different memory footprint between X1 and X1e. The key difference between X1 and X1e instances is the CPU to memory ratio. The X1 instances offer roughly 1:16 vCPU to memory ratio. So as you can see here, for 1 TB of memory, you get 64 vCPUs. So X1 instances offer two sizes, 1 TB of memory and 2 TB of memory. X1e instances, on the other hand, they provide much more memory for the given amount of CPUs. So considering that it's the same underlying platform, it still offers the same 122 vCPUs, but offers 1:32 vCPU to memory ratio. And we have total 6 X1e instance sizes, starting from 4 vCPU and 122 gig, going up to 128 vCPU and 4 terabyte. Specifically about the CPU and the compute platform, this particular platform is purpose-built for highly resilient, mission-critical in-memory workloads. We chose the Intel E7 CPU, which is optimized for enterprise-class database workloads. It offers Intel AES-NI and TCX. It also enables the Intel AVX2 technology, and it offers high memory bandwidth and SDDC1 that overall allows high resiliency and high performance that is really required for large in-memory workloads. So with that, let's look at the spec. This is the specification overview of X1 and X1e instances in terms of vCPU, memory, local storage, networking bandwidth, and storage bandwidth. This is really important because as you look at your in-memory workloads, you want to make sure that the transfer of data between storage and memory and the other application traffic that the in-memory workload will serve can be realistically addressed by any platform that you select. And we have put in a lot of work to make sure that we address the demands of the most demanding in-memory workloads. So what you can see here is the X1 platform and X1e platform. They both support up to 25 Gbps of networking bandwidth. They also support up to 14 Gbps of dedicated bandwidth to Amazon Elastic Block Store, which is EBS. What is important to note here is that we are able to improve the performance of network and storage in real time. That means once we launch these instances, we are actually able to bring improvements to the networking and storage performance. So to give you an example, when we launched the X1 instances last year, we launched them with 20 Gbps of networking and 10 Gbps of dedicated storage bandwidth. When we launched X1e this year, we also brought performance improvement for network and storage for X1 in real time. And when that happens, we make it available to the existing customers. And this is the innovation that we have brought through our Elastic Network Adapter that allows us to offload the networking stack from the hypervisor into the physical hardware for networking. And then it allows us to essentially make improvements to that networking stack without requiring a totally different instance hardware. So we'll continue to bring improvements in this instance specification. So let's talk a little bit about the underlying compute platform. It's a 4-socket Intel E7 platform. The 128 vCPUs are served by 32 vCPUs per socket and 976 GB of memory per socket totally gets you to the 4 terabyte of RAM. When we started building this, we put in a lot of effort to make sure that we can support NUMA-optimized workloads, and we can provide high memory bandwidth and low latency while accessing distant memory. We have done exactly that. We work very closely with SAP to make sure that the SAP HANA workloads and the performance requirements are met by this platform.
That's exactly right. We did a lot of testing to make sure that latency from remote memory was actually optimized for the HANA workload. That it required some tuning, obviously, at the hypervisor level to make sure HANA, which is NUMA aware, could actually see the correct topology and the right pinning. The other thing that we did is we actually leveraged a homogeneous and symmetric placement of DIMMs across each of the sockets, again, specifically to make sure that we have the correct bandwidth, throughput, and latency from a memory perspective.
So this is the largest memory available on EC2 today. And this is the compute platform that also serves the smaller memory sizes. So we talked about the specifications, but specifically for this largest instance size, It offers 4 TB of RAM. That means you can scale up your in-memory workloads, for example, SAP HANA, up to 4 TB in a single instance. You don't have to start with 1 terabyte instances and then scale out. If your workload supports scale up, you can scale up to 4 TB. It offers 128 vCPUs, which in our experience is a lot of compute for these kind of workloads. And right now we're shipping with 25 Gbps of elastic network adapter and 14 Gbps of dedicated bandwidth. Also very important, we also have local SSD stores. This is non-persistent storage, just like your local storage in the server, that's available to these instances. With that, let's talk a little bit about storage. So let me ask a question. How many of you are over-provisioning storage today in your on-prem environments? Over-provisioning either in terms of capacity or in terms of IOPS or throughput or any other metric? Yeah, exactly. So when we think about running large enterprise in-memory workloads, we also want to make sure that we provide an environment that allows the most optimization, not in terms of performance, but also in terms of flexibility and cost. We have a lot of different choices in the Amazon Elastic Block Store EBS product. And what this allows is essentially a collection of storage portfolio or storage services that allows you to start with one particular storage volume type and then select the right volume type as you change or evolve your workloads. So specifically, by the way, both of these instance types, X1 and X1e, are EBS optimized by default. And for anyone who is not familiar with that terminology, that means we have dedicated network pipe going to EBS for both of these instances. So we have two main categories of EBS volumes, SSD-backed and hard drive-backed. In case of SSD-backed volumes, we have provisioned IOPS, which allows guaranteed, consistent IOPS performance. And we have general purpose SSD volumes, GP2, which essentially allows, which provides enough IOPS for general purpose workloads. So when we launch IO1, we allowed customers to select how many IOPS they want, and for that IOPS, we provided consistent performance. Based on the years of understanding the customer behavior and workload behavior, we realized that most workloads can work with a certain number of IOPS. And based on that understanding, we also launched the GP2 volume that allows most workloads to get the sufficient performance at a reasonable cost. Now, if you have, if your workload is more throughput optimized, and if you have large block IOs and serial IOs, then you might want to also consider the ST1 volume, which provides very similar throughput profile compared to the IO1 volumes, but at a more optimized price point. The SC1 volume is essentially the coal volume that allows multiple different use cases like backup or log volumes, which are not really required to have large amount of IOPS. So with that, let's move on. When we launched the EC2 instances, one of the key features that our customers loved was the ability to spin up and spin down on demand and have the elasticity as they need. And we heard a lot of feedback that the customers would like the same level of elasticity from the EBS volumes, and we provided exactly that. So now with EBS, you can resize your volumes, you can change your volume type, you can select the volume characteristics live without affecting your workload or without affecting your workload performance. So that means you can start with, let's say, GP2 volume. And once your in-memory capacity increases and you want larger capacity to match the in-memory capacity, you can just increase your volume size or add new volumes in real time. At the same time, If you really think that now you're moving from test dev or QA type environment to more production-focused environments, you can also move from one volume type like GP2 to another like IO1 to guarantee certain IOPS without actually creating a downtime for your environment. So this really allows you the flexibility of selecting the right storage workload or right storage infrastructure as and when you need it, instead of trying to deploy everything that you might need in future. So this takes the risk of future growth planning away, and this essentially allows you the ability to start small, start with what you know today about your environment, and then grow and evolve as your workloads evolve.
Can I give an example for now? So consider in-memory databases, right? So the idea is to run most everything in memory, right? So there's typically a long duration to load 4 terabytes of RAM, and the single constraint often is throughput at the storage layer. In-memory databases are typically optimized, at least at the startup time, to actually use large block sizes. So one thing we've actually seen customers do is leverage the IO1 volume type, which offers up to 320 megabytes per second today, for heavy I/O operations that are typically required from in-memory databases. And then for normal operations over time in steady state, they'll actually change volume types to GP2, which is more in the 160 megabytes per second range, if that makes sense. And you can stripe multiple volumes together because the EBS volumes, essentially on the back end, we do mirroring of those. So.
And with that, let's also talk about some of the companion services. So let's assume that you have the right infrastructure in mind at EC2. You know that your workload can fit and run on the EC2 X1 and X1 instances, just like it would on your on-prem infrastructure. But it's not just the apples-to-apple comparison in terms of the memory or CPU or the storage capacity or the storage performance. EC2 also provides a lot of other services that collectively make the experience a lot more optimized for large enterprise workloads. We specifically want to touch on the 3 different services that we think are really helpful to customers running in-memory workloads. One is auto recovery. This essentially means that if your instance goes down for some reason, it will automatically boot another instance, apply all the characteristics of the instance like instance ID, your IPs, elastic IPs, and your storage volumes to the other instance, and then it will boot that instance. So essentially, this is your this is how you can get the resiliency without worrying about your HA plan or DR plan. If you're running a production workloads, you might very well have an HA instance running all the time. That's exactly what you might do on-prem. But here, you might not want to do that if you can work with the EC2 recovery and the kind of RPO and RTO it provides. So essentially, you can select a lot of parameters, and you can create a CloudWatch alarm and set up EC2 recovery, auto recovery. And when your instance goes down, the other instance will come up, and you will have your instance up and running. Same way with auto scaling. When customers run in-memory databases on X1 and X1 instances, a lot of the front-end applications run on a lot of other different instance types. And we've seen that these front-end applications are highly scalable. That means with demand, these applications scale exponentially over time. And with EC2 auto scaling, you can take the risk of growth planning out of that equation. What that means is you can dynamically add new instances or remove instances based on your workload condition. You can select policies, like you can say that when my CPU utilization goes to 75%, I want to spin up a new instance. But when it comes back down and it goes below 40%, I want to stop one of the instances. So you can have that dynamic addition or removal of instances based on your workload demand. And the last one is elastic load balancing. This really works well with the auto scaling feature, where you can balance all the incoming traffic and connection into the instance across multiple instances. So if you're running multiple front-end servers that are connecting to your in-memory database that's running on X1 or X1e instances, then you can use elastic load balancing to make sure that as you scale your workload using auto-scaling, you're also balancing your connectivity to that workload. So with that, I want to turn it over to Steve, and we want to talk about one specific in-memory workload so that we can dive deeper into how we have really optimized this platform for these kind of workloads. And we want to talk about SAP HANA.
Yeah. So before we dive into some of the specific use cases around SAP HANA, I want to back up just a bit and tell you how we actually got here, right? So we started with SAP back in 2008, right? AWS started in 2006. SAP was one of our first customers in 2008. Really doing some interesting things back then. And we started looking at being able to support mission-critical workloads back then. So we've got a long history at being able to support these type of systems. But you'll see here, as time went on from 2008 through about 2012 or so, we were working with SAP to really understand what it meant to support these types of workloads, and taking a lot of those learnings from early customers and actually baking them back into the platform, taking those requirements, and then building new additional offerings. As Pranav mentioned, our first instance type was M1. The first instance type we had certified for SAP was M2, 2X large. I think it had about 32 gig of RAM back then. So we've come a long ways since 32 gig of RAM up to 4 terabytes. What you see here on this timeline here is a whole bunch of SAP solutions, SAP Mobile, HANA Developer Edition, S4 HANA, and we really pivoted from certifying SAP solutions to actually building purpose-built equipment, right? We've pretty much largely certified all the SAP solutions to be run on AWS today by customers, and now we're actually focused on building purpose-built equipment for SAP. The funny thing is that just as many customers are running non-SAP solutions on X1 and X1e as customers are running SAP, and that's the fascinating thing for us. You'll see SAP too at the top part of this curve is now actually also building some of their platforms on us that take advantage of these large memory platforms. So you can see kind of the velocity of this investment, both in people, resources, and platforms, right? We could have taken off-the-shelf equipment and put it in a colo facility and connected it up through Direct Connect and had that as a solution. But when we went to talk to customers, this was not the experience they wanted, right? They told us they needed flexibility, cross-pricing, purchasing options, as well as deployment vehicles, and they didn't want something that felt a whole lot different, if that makes sense. So it took us a while. It took us actually about 2 years from idea. We started working with SAP on kind of what the requirements would be if we were to go build this ourselves, and then we went and built it ourselves. There was a lot of testing to make sure that a lot of the features that Pranav was talking about are actually working. I mean, there was a hypervisor. It was highly tuned and optimized to make sure we were exposing the right instruction sets. Again, the NUMA-aware capabilities and those types of things. And so today what you see is a very broad set of certifications for SAP HANA. So today we can support, as we've indicated here, up to 4 terabytes in single scale-up systems. We also completed work that will allow us to support very large distributed clusters of SAP HANA systems up to 50 terabytes. Now, I have to be honest, there's probably not a lot of customers out there that need 50 terabyte clusters, but there are some. But what this does show is that it's very highly capable from a platform perspective. Every single individual node has the same discrete amount of CPU and memory and networking and storage at scale, right? And so you can actually stitch a whole bunch of these together and get some really astounding performance. Just to give you an idea, a benchmark we recently completed with this 50 terabyte cluster, we loaded almost 47 billion records into this database. It was a very massive amount of data. All right, so here, and Pranav actually mentioned that we have a number of different compute instance families. We have also optimized our certification work with SAP for instance families that are applicable for SAP workloads, right? So we see customers often using The R family instance types for database servers, right? So a lot of databases, SQL Server databases, DB2, Oracle, being run underneath SAP systems today. And then obviously the higher memory instances for workloads like HANA. There's also a lot of application servers as well, application tier. Like Pranal mentioned, so we've done a lot of work in benchmarking very large distributed SAP systems that both comprise what SAP calls a 3-tier landscape with a distributed set of application servers in a single database instance. Most often we find customers using the C family for the application server tier and the M family often in non-production environments. For those of you that are SAP geeks in the room, you'll understand the term SAPS. So SAPS is a benchmark metric. It's a metric that equates to basically a throughput of what SAP calls SD benchmark documents or SD documents, and it's the number of documents that can be pushed through a given system in a 15-minute time frame. So we benchmark these so customers can actually size these and go through the normal SAP sizing mechanism. Sizing is important, but it's okay actually now to get sizing a little bit, it can be a little bit off, and I'll explain why that is in a moment. So we've talked a little bit about the technology platform. I want to dive a little bit into some of the automation that we've done, specifically around SAP, but it's also applicable to other in-memory database workloads, other workload types as well. And then I want to talk a little bit about some of the programs we're helping customers as they look to migrate some of these systems. So how many of you have heard of AWS Quick Starts? Excellent, excellent. So Quick Starts are automated reference deployments for many of the key workloads that our enterprise customers are running on our platform, right? So across a whole litany of use cases, pick Microsoft, for example. So if a customer wants to deploy a very large distributed SharePoint farm, like is often the case, we have a single button deployment that actually deploys that in a highly available manner across availability zones using the proper architecture for resiliency and high availability. There's a lot of other quick starts. Today we've built actually more than 50 of these. And the idea is that the feedback from customers were when they're coming to our platform to run some of these very mission critical workloads, they would often spend a lot of time researching just what the right architecture pattern would be. And we'd spend a lot of time with them, right? Being customer assessed, we want to make sure they're going to be successful, right? So we've done a lot of the heavy lifting. These are all based in CloudFormation. So CloudFormation is essentially a scripting language based in JSON where all of the AWS components can be orchestrated in a single JSON template or multiple JSON nested templates, and then fed into our CloudFormation tool in essence. And we, on the back end, we'll parse that and we'll actually orchestrate the infrastructure. Using code, we'll actually inject parameters on the fly and orchestrate much of the provisioning of the software stacks that go into Quick Starts. These are free. We don't charge for these, and they're really available. So we have some for SAP, including SAP HANA. Customers actually today will pay tens of thousands of dollars to have an appliance vendor come in and install a HANA appliance in their own data center. These are typically single rack or multi-rack, depending on if it's single node or scale-out configurations. So they can be very complex to fit into a data center and to rack and stack. So again, we've done a lot of the heavy lifting. We can orchestrate the entire setup from initial VPC design, standing up the instances, attaching the proper storage configuration that adheres to SAP certification guidelines. We tune the kernel, we install HANA, and all the various things that go into actually making this run really, really well. If you already have a VPC, this is something we can also leverage. So it's just an option, and I'll show you this here in just a moment. You can deploy it into an existing environment and then hook it into your current application stack. We've also developed what we call the NetWeaver Quick Start. So NetWeaver, for those that aren't familiar with SAP, is the application stack that most of the SAP modules run on top of, right? So customers who are running ERP are running on a NetWeaver application server, right? And so we've automated the entire setup of this application server as well, again, in a highly available manner so that working customers actually wanting to deploy this don't necessarily have to, again, go through all the motions and trying to figure out what's the best manner in which to do this. Our solution architects have done a lot of work in working with customers and have baked this into the Quick Start here. Customers with SAP workloads often have varying workload profiles, right? Some are batch heavy at different times of the month, or some systems are just architected differently depending on if it's a different industry or vertical, right? And so we start with some t-shirt sizing, workload types, but customers, by selecting some of the parameters, which I'll show you in the quick start here in just a moment, can actually optimize the actual deployment. So let's actually dive into this now. I'm going to ask you to strap in just a bit, because so the HANA Quick Start itself, end to end, runs about 30 minutes, right? So I'm not going to make you sit here for 30 minutes to watch the HANA Quick Start. The NetWeaver Quick Start end to end runs about 3 hours. I'm also not going to ask you to sit here for 3 hours and watch that either. So what we've done is we've recorded it, we've cut it out, we've cut out a lot of the processing steps, the software installation, so you can actually see what the process looks like. So let's dive in here. So like I mentioned, this is based in CloudFormation. So I'm going to go into the CloudFormation console. You can actually navigate to this from the Quick Start microsite on the AWS homepage. Actually, I'm going to start it now. There we go. So we click into CloudFormation. Again, it's a single template. It's a very long template with a list of parameters that outline exactly what we're going to be deploying. Here I'm actually going to paste in a URL that has a link to the template. Again, this is not necessarily something you have to do if you navigate to from the AWS homepage. Here we're going to actually just give the stack a name. All the resources that get created with this CloudFormation template, this Quick Start, will be tagged with this name so that you'll actually be able to identify the resources that were created along with this. We've actually separated some of the parameters that you can define into logical groupings. So this first set of groupings has to do with networking, the infrastructure. So here I'm actually selecting availability zones where I want to actually distribute my application tier. I'm going to choose 2 for a highly available architecture. You can see here I've outlined the VPC CIDR block and subnet CIDR ranges as well. For the HANA server and storage configuration here, I'm choosing SUSE Linux 12 SP1. Here I'm actually passing in or actually naming the HANA server itself. This will actually be pasted or passed into Cloud Init actually as we do the deployment. I'm choosing a 2 terabyte instance, X1 32 extra large. Choosing to deploy 1. You can actually deploy clusters, as I indicated earlier, of SAP HANA systems. You can choose to enable encryption of the EBS volumes or not. I'm going to use the GP2 storage volume. You can choose IO1. And remember, you can change this on the fly after the fact. Now, we don't have distribution rights for SAP software. So as customers, you need to download this software and place it into an S3 bucket or a location of your choosing. You just need to tell us where that is, and then we'll orchestrate the software install for you. And this is all done within your account, so it's not like we ever have access to that software. Now I'm into the SAP application tier cluster setup. I've chosen an operating system there as well. I've turned on EC2 auto recovery. So in case there are any failures there, it'll automatically just recover that for me. I named the host. For those of you that know SAP lingo here, I'm able to set things like the system number, the system identifier. Again, completely customizable. We use Systems Manager parameter store to actually securely store the passwords. So the passwords that you set in here are passed into the parameter store for secure handling. Similar thing with the software for the NetWeaver stack. You just need to tell us where you put it. And you can actually choose whether or not to install the SAP software or not. If you want us to orchestrate that for you, we'll absolutely do that. But if you just want us to set up the infrastructure, you can select no. We have some auto-scaling capabilities, as Pranal mentioned. And this actually allows you, again, to turn on auto-scaling for the application tier if that's something you would like to do. You can choose how many application servers you want to auto-scale up to, and the workload type, whether it's dialogue, which is dialogue is typically user heavy, right? User interaction heavy, or batch. We deploy an RDP instance, so you can remote desktop into this working environment. We also provision a Linux Bastion host for secure SSH access as well. I'm going to tag this SAP demo. Again, this tag will actually be applied to all the resources that get provisioned so that you can actually go and search for resources. So here's a long listing of all the parameters we just entered, right? I'm going to hit the magic create button. And this is where we've pulled out a lot of the timeline. We're in the console here. You can see that we're creating a lot of resources. Here what we've done is we've actually split up each of the creation scenarios, the HANA database, the actual VPC setup and creation, the application server into different stacks. So you can actually take this, customize it as you see fit, use what you like, and throw out what you would like as well. Here you can see that end-to-end, the process itself took just about 3 hours. So again, I didn't want to actually put you through that, but you can see that we can actually orchestrate a lot of infrastructure configuration in a very short time period. These are the actual virtual machines that were created, including the HANA master there you see is the 2 terabyte instance. We've got our Linux and our Bastion server. So what I'm doing here is I've actually remote desktop into the Windows server that we deployed. We've installed HANA Studio so we can actually look and see the resource utilization for HANA. Here you can see I've got just about 2 terabytes of RAM for this X132 extra large instance. The HANA host name was actually passed in correctly. You can see that we're using SUSE Linux as we selected as well. If I go to the landscape tab, these are all the various HANA services that are actually running at the operating system level and it is exposed up through the HANA Studio. For those of you that know SAP, I'm going to log into SAP GUI now since we actually orchestrated the install of the SAP Application Server tier as well. So here I'm logging in with SAP user DDIC. I'm going to navigate to a traditional transaction that SAP Basis administrators use, DB02. I can take a look at the database profile and usage from within the SAP application. So if we just look at the overall area here, again, you can see from within SAP, we're actually running on a 2 terabyte instance as well. Also from within SAP, you can see that all the storage configuration, all that has actually surfaced up into the SAP application layer as well. So your basis administrators who are used to actually administering SAP systems from within the SAP application, all that information is still exposed into the SAP application layer as well. So let's dive into maybe a real-world example here really quickly. So we had a customer, Fairfax Media, based in Australia. So they started with us on an instance type R3 when they went into production with their BW environment. And they started with what they thought was reasonable, right, 244 gig instance. Within 6 months, they quickly realized they were outgrowing this. At that point, our next instance family, instance type that was available was the 2 terabyte instance. We had not released the 1 terabyte instance or the R4 half a terabyte instance yet. So they quickly scaled up using a simple stop-start exercise, which we'll show you here in just a moment, and it took them less than an hour, right? So consider what this would actually look like in an on-premise world, right? We're looking at potentially data migration or significant downtime to have a hardware vendor come in and stick additional memory in a system if it would accommodate that. So it's a much different value proposition. The customer is actually taking advantage. Bernard, you want to talk just real quickly about how this works?
In that exact process that Steve just described and how it would actually occur in an on-prem environment, working with vendors, selecting new hardware, migrating your workload to the new hardware, that would be a totally different process and a totally transformative one in EC2. So let's say you are running your SAP HANA workload, or for that matter, any other in-memory workload on X1 instances today that offers 1 terabyte and 2 terabyte of memory. Let's say you start with 1 terabyte of memory. Now you realize after 6 months that you're running out of memory and you need more memory capacity. How do you move to a larger instance, let's say to a 4 terabyte X1e instance? It's pretty simple. You turn off your application, you shut it down using your standard console or API method. then you go to the console or to the same API, and you can change the parameters of that instance. You can change the instance to the new instance type, which is, let's say, the 4 terabyte X1e instance. And then that actually maps all the instant attributes from the old instance to the new instance, including your storage volumes and your IP addresses and everything else. And then you boot that new instance, and then your SAP HANA is now running on 4 terabyte instance. It's that easy. The whole process was completely in the background, and the application was completely agnostic of what just happened. Because as far as the application was concerned, nothing really changed in terms of the instance parameters and IP addresses and storage volumes and all those things. So this allows you the flexibility to start small, not overspend, and then optimize later when you really know that you're going to need that more memory capacity.
It works the other way too, right? So we have customers all the time that go through standard SAP sizing processes, and it's often overestimated. And so they go through a migration process, they end up landing on a 4 terabyte instance, and are like, I really only need 2. So they can actually scale back down the other way. So let's show this to you. This one's super fun. We're back in the SAP system now. Remember we provisioned an X1e 32 extra large, an X1 32 extra large system with 2 terabytes of RAM. So what we're going to do, I'm going to actually leave SAP up here, and I'm going to SSH into, I'm going to go through my Bastion host. I'm going to SSH into the HANA database server. So I'm going to switch users to the database administrator user. We're just going to take a quick look here to make sure we're on the right system. Okay, this is my 2 terabyte system here. You can see here that it's roughly 2 terabytes. We do a quick process listing. You can see the HANA is up and running. HDB info shows me again the process tree, which we saw within HANA Studio just a minute ago. I'm going to stop the database using HDB stop. And that's all I'm going to do on that instance. And I left the application server up and running. Now, SAP customers, obviously, we're going to do this during a maintenance window, but I want to show you what the effect is of what we're doing here. So now I'm back in the AWS console. I chose my HANA system using the X1 instance. I'm going to stop it here. And this is about a 2 to 3 minute exercise. So it doesn't take much time at all. We wait for this to stop. And then once it's stopped, again, I can either issue an API call, or I can just choose off the actions list here, change instance settings. So here I'm able to choose any number of instance types, right? There's a lot of them. I'm going to scale up this time. I'm going to go up to 4 terabytes of RAM. Just say apply. Again, that's all I have to do. From here, I'm just going to say action start. And then again, wait for another 2 to 3 minutes. It's that simple. So at this point, I've not done anything with my storage volumes. I've not had to migrate data. It's just all coming along with this metadata that comes with my instance, right? It's automatically mapped in the control plane. So you can see here, we have the instance is now up and running. So I'm going to actually log back in. Let's take a quick look here. You see it's up and running here. So we're back on the Bastion host. I'm going to SSH back in now that the system's back up. I'm going to switch users back to the database user. Let's see how long the system's been up. Okay, so it just booted, so it's not been up for too long. And now we're going to actually see how much RAM is available. Ah, look at that, just about 4 terabytes of RAM. Now we've actually, as part of the orchestration process for HANA, as part of Quick Start, we have set some auto start parameters so that HANA automatically starts after a system boot. So you can see it was up there. I'm back within SAP, which again I left up, if you remember. I'm just going to hit the refresh button here. You can see that immediately from within the application, I can see my database server now has double the amount of RAM there with 4 terabytes of RAM. So similarly, I can actually do volume extension, right? So let's say I need to extend my volumes because the size of my database, I expect it to grow. I can issue API calls as well to extend those storage volumes. So I want to talk just a little bit about some programmatic stuff that we've been doing with SAP as it relates to moving these mission-critical databases and helping customers do this. And it's a combination of this program as well as tooling. A lot of customers have questions about HANA and if it's right for them from a timing perspective. I don't know how many people are aware that in essence, we've got a tool that SAP has had over the years. It's called DMO for system move, excuse me. Prior to just recently, it used to be that if you were going to migrate an SAP system on any database to HANA, it would actually require close proximity, right? So you would have to have some sort of hardware in your data center in order to accommodate the move. So working with SAP, we're actually able to now extract or dissect the extract process from the import process, such that we can do some interesting things and we can automate a lot of this. And this is part of what we call the Rapid Migration Program or FAST program. And the idea is to help a customer experience a copy of their production system on AWS in record time, so that they can get answers to questions like, what does my ECC system look like on top of HANA? Does my month-end process run any faster? And help make that business case for when it makes sense for them to actually move. We've done this with a number of customers now. Just about 3 weeks ago, we finished a customer that had a 25 terabyte source system. And they migrated it to a 5-node scale-out cluster for HANA on AWS, X1 32X large cluster. The actual migration time took us about 42 hours end to end, so highly optimized. We've had some customers with single-node systems in the 2 to 3 terabyte range. We've been able to actually get that down to about 29 hours. And we're learning that we can actually parallelize the export and the import process at the same time. So this is a program that we're actually working together with SAP, our professional services, and also training partners on how to execute this program for customers. So here's just a high-level diagram on how this works. The DMO for System Move is actually SAP software that any SAP customer has access to. It comes with their SAP licenses. It's not something that has to be paid for in addition. This can be deployed on premises, on a spare application server, or it can actually be deployed on AWS. It doesn't really matter where you put it. As the export is occurring, you can be spinning up the infrastructure on the target side using the Quick Starts. The other thing that's really interesting with DMO for System Move is that it's actually converting the system to a HANA format as it's being exported. Not only can it convert the system to a HANA format, it can also upgrade at what SAP calls enhancement packs or versions, and it supports going all the way back to very old R3 versions. Now, obviously, there's the import then on the target side. So this is happening, right? There are a large number of customers, SAP customers, running their workloads. In fact, there are thousands of SAP customers running SAP workloads on AWS. And there are hundreds of SAP customers, enterprise customers, running SAP workloads on our platform. In fact, in the period from 2014 to 2017, the compound annual rate was around 45% of customers adopting our platform for SAP workloads. You'll see and recognize many customers up there like Bose, Hoya, Zappos, BP, doing big things. Running SAP on AWS, there's some subtle nuances to it. So we've actually put a lot of effort into documenting a lot of this work and how to actually make this more streamlined. And so you'll find a lot of information on our microsite about this. There's the information about the FAST program and how to get hooked into that and get started there as well. We've got instance pages directly attributable to X1 and specific information around that. For now, anything else you want to add?
No, so we have really good technical documentation. So apart from these pages, feel free to go to the AWS Tech Docs, and you can find a lot of information around not just X1 and X1e, but the entire EC2 platform and all the different services that we talked about. So with that, we would be here and outside in the hallway. So if you have any questions, reach out to us, talk to us. We'll hang out here for a while.
Yes, and thank you for coming.
Thank you.